Hello everybody, welcome to this new video. In this video, we are going to discuss the concept of significant figures. That is, when we note down a number, how many figures in it are significant, that is, meaningful or certain, and how many figures are uncertain, that is, where we might have gone wrong. Understanding this concept is very important because while doing mathematical operations like addition, subtraction, multiplication, division, etc., the final value should be reported according to the concept of significant figures. Let us see, for example, this calculation we have done in the previous video in the interconversion of mole fraction and molality. We got the final value as 0.20016 and so on, and we reported the value as 0.2. There we did not take into account the concept of significant figures, but actually whenever we do mathematical operations, the final answer should be reported according to the concept of significant figures. In this video, we are also going to discuss two terms, precision and accuracy. So this is of great importance, and this will help you not only in chemistry but also in physics and mathematics and all other fields where calculations are done. So watch the video completely without skipping. Like the video and share the video with your friends and other groups so that they may also be benefited. And if you have not subscribed my channel, please subscribe my channel and also press the bell button near it so that you get intimated as soon as new videos are posted. Please go through the description box also, where I will give details of this video. Thank you very much. Now let us continue. In the practical class, we take measurements of different quantities. Say for example, thickness of a glass plate, mass of a substance, volume of a gas, etc. These measurements can be 100% correct only if the readings are taken in ideal conditions. So only ideal readings or measurements can be 100% correct. But the actual reading may definitely show some deviation or variation from the correct value. That is, errors may crop in. Errors mean deviation from the actual reading. What is the reason for these errors? The errors may be due to personal limitations or limitations in the instrument or due to limitations in the conditions. Whatever may be the reason, errors are always possible. So, how is this overcome? This is overcome by taking several readings of the same quantity. The experiment is repeated several times and their average is taken. The average value that is obtained like that is taken as the true value because true values are hypothetical. So the average value is considered as the true value. The validity of the reading taken are described in terms of two properties called precision and accuracy. That is, the values are either accurate or precise. Let us see what we mean by this. Say for example, a reading 9.95 and there is another reading 9.93. These two readings are very close. There is only a variation of 0.02. So these two readings have closeness. So closeness of various measurements is what we call precise value. Then what is accurate value? If the reading agrees with the true value, then it is an accurate value. Then what is accuracy? Agreement of a particular value with the true value is accuracy. Say for example, consider two readings 10.01 and 9.99 and the true value is 10. The two values are close and it also agrees with the true value, so it is accurate. So the values are precise and accurate. Some values may be neither precise nor accurate. That is, there may not be closeness of the various measurements that is taken and its average may not agree with the true value. So when we note down a reading, there is a certain amount of uncertainty in the reading, but which part of the reading is uncertain? That is, in which part of the reading we have chances of going wrong. Consider the value 10.01. The first part is a bigger value, it is certain, but the second part we may have gone wrong. Say for example, we are measuring length. We are using a scale. The first part of the reading 10. We may not go wrong while taking that reading. But when we take the reading 0.01, we might have gone wrong. It may be 0.00 or it may be 0.02. So this part of the reading is uncertain, and the uncertainty is in the last digit. It may be plus or minus 1. Now we will proceed to understand how the number of significant figures in a number is decided. I have already given a few examples of numbers. Let us see one by one. The first number 2.020. How many significant figures are present in this? There is a decimal point. There are non-zero digits and also zeros. What are the rules? Zeros at the end of a number with a decimal point are significant. Zeros between non-zero digits are significant whether the number is with decimal or without decimal. Similarly, all non-zero digits are also significant. So, there are 4 significant figures in this number. Next number is 0.020. There is a decimal point there. There is a 0 at the end. There are 2 zeros in the beginning. There is a non-zero digit. So what are the rules? Zeros preceding the non-zero digit are insignificant. They are not significant. And zeros at the end is significant. So altogether there are only 2 significant figures here. The next number is 0.200. There is a decimal point, there is a non-zero digit, there is a 0 in the beginning and 2 zeros at the end. So taking into account all these rules, we find that there are only 3 significant figures here. The next number is 2020. There is no decimal point. There is a 0 between the non-zero digit. There is a 0 at the end. So from the rule, zeros at the end of numbers without decimal point are not significant. So here you will have only 3 significant figures. But if you put a decimal and put a 0 at the other end, then the number of significant figures become 5. 20 apples is a number pertaining to counting. So when it comes to counting, you can write this number as 20.00, any number of 0. The meaning does not change. Zeros at the end of a figure with a decimal point are all significant. Therefore, the number of significant figure becomes infinite. We cannot say how many significant figures are there here. So these are the rules to be remembered. Such questions do come for examinations. So be thorough with it. It is very simple. The only thing is you have to remember a few points. Now we have to see how mathematical operations and significant figures are related. Now we will see how significant figures are taken into account when results are reported in mathematical operation. First, we will take up division and multiplication. I have given here 2 simple cases of division and multiplication. Let us see the rule. The result should be reported as having significant figures not more than that with the least number of significant figures. 9.990 divided by 2.51. Here the figure with the least number of significant figures is 2.51. When this is simplified, the answer that we get is 3.98007. But when we report the answer, it should have only 3 significant figures. So it will be equal to 3.98. Multiplication 1.5 into 2.01. The result is 3.015. Here there is one number with 2 significant figures, another with 3 significant figures. So the answer should have 2 significant figures. That is 3.0. It is not 3, it should be 3.0. If you write 3 only, there is only one significant figure. Now let us see addition and subtraction. What is the rule? The result should be reported as having decimal points not more than that with the least number of decimal points. So here the decimal point is considered. 2.01 plus 2.1 is equal to 4.11. But the answer should be reported as having only one decimal point, that is 4.1. Similarly, subtraction, 2.01 minus 0.025. You should not add one zero here. Then the number of significant figures will change. It should be subtracted as such. Result comes to 1.985. But while reporting, we have to take into account only 2 decimal points. If the last number to be dropped is 5, there is a rule to be followed. We are rounding off the figure. The rules are mentioned here. This particular rule has to be taken into account. Last digit to be removed is 5. The preceding number is an even number, 8. Then no change in the preceding number. So the answer will be 1.98. 5 is dropped. No change is done here. The last digit to be removed is 5. The preceding number is an odd number. Then increase by 1. So 2.33, 5 becomes 2.34. Now the remaining two rules. The last digit to be removed is more than 5. The preceding number is increased by 1. 2.346 becomes 2.35. Last digit to be removed is less than 5. No change. So the answer will be 2.34. Let us recall the question that we gave in the beginning of the video. 3.59 divided by 0.99641 into 18 is equal to 0.20016. The answer should be 0.20. In the question, there is a figure with 2 significant figures, that is 18. So the answer also should contain 2 significant figures. That is why the answer is chosen as 0.20. I hope this video was really useful to you. We will meet in the next video with a similar useful topic. Thank you very much.